So we're going to talk about quadratic functions, and later on this cover I might add a few things just as a refresher, but just start on page 2 right now. So last year, if you took intro, we talked about linear functions and linear functions that have the equation y equals ax plus b. You may have looked at it. Did you use mx plus b? Most likely, m is the slope. Yes, you are right, but in general, the variable with the greatest power, we're going to have an a in front of it. In this case, x to the 1 is the highest power of x, so we have a in front of it, and then b next, okay? Where a is the leading coefficient, it's a bit tight, so try to make this work. Leading coefficient, and the constant b is the y-intercept, okay? It produces a straight line since the highest power of x is 1, okay? And the equation therefore has a degree of 1. Do you need a refresher on x and y-intercept? Okay, so you have your x-axis and your y-axis, and if you have a straight line, this is your y-intercept. It's where the line crosses the y-axis, and this is called the X-intercept. X-intercept. I'll review that anyways, but if you're a bit like, what is a y-intercept? That's what it is. Note that y is equal to ax plus b may also be written as mx plus b, doesn't matter, where m is the slope and the constant b is the y-intercept. We'll do more slope later on. We will do linear again, so for now I'm just going to leave that. A quadratic function has the equation y equals ax squared, so notice that the a is now in front of the x squared, plus bx plus c. And a cannot be 0 because then it would no longer be a quadratic. Anything that has an x squared or an m squared or anything squared in the equation, we call that a quadratic function. B and c may be 0. So just a note, a, b, and c can be any number you'd like, except for a cannot be equal to 0. That's the only condition. Where a is the leading coefficient, and the constant c is we call it the constant, meaning it doesn't change, it's just a fixed number, is the y-intercept. It produces the shape of the graph is what we call a parabola. Since the highest power of x is 2, the equation is known to have a degree of 2. A quadratic function will always produce a parabola, and it can point either up or down and expand sideways indefinitely. So pointing down, meaning the ends that have arrowheads in this case, point down, or it could be pointing up like this. It opens up indefinitely, right? So it's not a U, right? It's not a U. This would be incorrect, right? Like that means that they go parallel, they go like this, so don't do it like this, okay? So again, state whether each of the following would be a constant, a linear, or a quadratic function, as well as is there one that doesn't apply to what we're doing right now. This one is a quadratic. It has everything we're looking for. This one right now is NA, because we don't know if this line is actually going to go back up. We don't know that. Next year in grade 12, you will explore that. This one is also a quadratic. It has the parabola shape, and it's pointing down. What's this one here? Linear. I hope you know that one. What's this one? This is a constant. Yeah. And I'll tell you what that looks like. The equation of a constant function simply looks like this. Example, what do you think this is? Like if you estimate 1, 2, 3, right? Right there, that would be coordinate 0, 3. So the equation would be y is equal to 3. It's that y value. What's this one? Kind of looks like a parabola, right? But it's sideways, so we can't have that. So this is not applicable. The only quadratic functions that we've identified here are these two. Those are the only two shapes, the only two ways that they're going to be facing. Okay? This is a blast from, well, not the past necessarily, but some components. So I want you to look at the degree of all of these functions here. So you look at the first one, the highest power of x is 1. So therefore, the degree of this entire function is known to be 1. This one over here, what's the degree of this one? It's not 1, right? There's no x. Would you be, if I told you that there's a x to the 0 there, what is anything to the power of 0 is always? Is always 1. Anything to the power of 0 is always 1. A million to the power of 0 is 1. Negative 500 to the power of 0 is 1. Okay? So the degree here is 0 because the highest exponent power of x is 0. Okay? What about here? Highest power of a variable is 2. Highest power of the variable is 3. This one is, I was wondering if you would remember, it's really saying this. Do you remember, I don't want you to stress over this one, but do you remember if you bring anything up, you just change the exponent, you change the sign of the exponent? We're just going to leave it. So we'll just go NA here. What about this one? What do you think this is going to end up being? 2. Yeah, it's going to be 2. And the reason here, luckily for you, you're not going to have to factor. You're not going to have to factor in this class. But I would expect you to be able to FOIL this out. Do you remember that? FOILing out, like distributing, multiplying these two things? Basically, watch here. Just copy this down under. The 6 stays. But what I do is I take the first one here. I take x and I say x times x is x squared. X times 3, positive 3 that is, plus 3x. Okay? Then you move over to the second item here. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. And then we clean this up. X squared stays. 3x minus 5x. Well, how many x's are left? Negative, right? Negative 2x minus 15. And last but not least, you multiply the 6 throughout the whole thing. Okay? So it's 6x squared minus 12x minus, that would be 90. So this is technically the function. Now you can go f of x at the very end. F of x or y, it doesn't matter. It's still a function. And so it's a degree of 2. Type of function, linear, constant, quadratic. What do you think a degree of 3 will be called? What do you think it's going to be called? Cubic. Yeah, cubic. I know you knew it. I know that. If not, you ask ChatGPT. We'll just go NA. It's called an inverse, this one, but quadratic, you're not going to see that one, not if you stay in applied. So we're just going to leave that. Okay. Leading coefficient. The leading coefficient is always found, listen carefully, in front of the greatest variable, like the variable with the greatest power. So over here, what is in front of x right now? A 1. There's a 1 in front of it, so the leading coefficient is 1. What would you say here? 15 technically. Over here, x squared, right? So in front of x squared, we have negative 3. Over here, what's in front of x cubed? 1. We also have a 1 here technically. And over here, what's in front of x squared? It's a 6. There we go. So this is, I would expect you to do this, no problem. How about the constant? The constant in the first one is just the number. So if you want to make a note, just the value, right? Just a number by itself. That's what a constant is. A number by itself. So 7. Over here would be 15. Over here would be negative 5. So you got to make sure the sign and everything goes with you. Over here, what's the constant here? Don't forget about the power of 0 as well. There's a 0 tagging along. It's just we don't add it in our notation, but it's there. Technically here it's 0 as well. And over here, the very last one, negative 90. Okay, negative 90. So there you have it. That's how you kind of read the functions. The most important one, I want you to be able to look at a quadratic and be able to identify the leading coefficient and the constant right away. Okay, keep going. Let's go to page 3 here at the very top. So I'm going to kind of overwhelm you with information today. I'm just going to be honest. Okay, the general form, the quadratic has the general form, most famous, most popular. Then there's the descriptive, the vertex form, and then there's the factored form. There's 3 ways to talk about it. Stop here, pause. If you took intro, do you remember linear equations? There was more than one way to state it. Slope, intercept, point slope, that fancy stuff. Same here. The beauty of this course, however, is it doesn't matter which form I will be giving you, you can always enter it into your calculator and graph it. So it doesn't matter whether or not you identify it right away, you will be able to solve it with a calculator. So general form looks like this. Y is equal to ax squared plus bx plus c. Mr. Dirksen, will always be plus, right? Because you're telling me that? No. B could be a negative. C could be a negative, A could be a negative, okay? But this is in general what it will look like. And what does this one give us right from the get-go? Gives us the y-intercept, okay? I would actually say at the end by the end of today, you should have this on your study sheet for the lessons coming up. The y-intercept, it is actually 0. The coordinates of the y-intercept would be 0, c. Okay? So whatever this value is, that is what goes in there. And so that's where the parabola will be crossing the y-axis, just by looking at it. Descriptive of vertex form, it looks like this. So you copy this down, okay? And now the most important part that a lot of students forget is make sure this is squared. Okay, this bracket here is squared, or else you don't have a parabola. You'll have a straight line. This one gives us the vertex. It gives us the vertex, not the y-intercept. It doesn't give us the y-intercept just by looking at it. So a lot of students are like, oh, okay, that's the y-intercept right there. No, remember there's brackets here with a squared. You can't do that. This gives us the vertex, and I'll explain what the vertex is in a bit. So basically what you need to do, if you have a different color, I will use a different color. You look at whatever number is in here, you change the sign of it. That's in math, when you put a negative in front of something, it says whatever it is, we're going to change the sign to it when we put it in here in our vertex. K. K stays the same. K does not change. Okay? So I'll make a note here. Note, negative changes the sign. Can I say the OG? My kids at home would say that's lame. That's very lame. Don't use that. Okay. Negative changes the OG sign. So what I mean by that is the original sign. So whatever is in here, that negative will change it when you take it out. So let's say this read x minus 5. You're like, oh, h is minus 5, right? When you put it in here, you'll change it to positive 5. Okay, so that's what I mean by that. You're probably thinking, what's the vertex, Mr. Erickson? This is nonsense. What's vertex? I think I'll just quickly tell you what the vertex is. Look up here. A parabola, right, in this case would decrease, 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 decrease. But there's a point where it reaches the lowest point and then it goes back up. This is the vertex. It's the lowest point in this case. But what do we know about a parabola? It can also look, it could also be pointing down. We call that the vertex. So it could be the highest point, it could be the lowest point, but regardless, it's where you change direction. It's a particular point where you change direction. So if you look at this format and you recognize, how will you recognize it? There will be a bracket and a squared and then potentially a number just hanging around here. You know it's in this format, and so you know the coordinates of this point just by looking at this. Okay? That's what I'm trying to say here. More later. I'm overwhelming you right now, I know that. But more on this later. Factored form looks like this. It'll be x plus r and x plus s. I don't know who came up with this, but that's what most textbooks do. Rx. So basically, this gives us the X-intercepts. X-intercept or intercepts. Okay? So the first one would be x. Oh, sorry. Don't copy this. Undo. The first coordinate would be negative r. You take whatever this number is, change the sign, 0. And the second x-intercept would be negative s, 0. Let me give you a quick example just above it. So I'm going to cut this here. I'm going to make this be part of the vertex form. So let's say you have, this is your x and your y. And your parabola goes like this. How many x-intercepts does this thing have right now? It has one here and one there, correct? So this would be the first one, and this would be the second one. So that's what this format gives us right off the top. Okay, so this is your x-intercept. X-intercept number 2, this would be x-intercept number 1. So if you want to copy that, if you need a bit of a refresher, please do that. I want you to, it's important to have this whole thing on your study sheet. And if you need to have those little diagrams that I added, so be it, okay? And yes, you may have to change it, you may have to add things to it later as you go through the course. You're like, you know what, Mr. Dirksen, this doesn't help me. I need to have an example of this. I need to have like an actual specific example right underneath this for me to understand. Absolutely. Okay? All right, let's keep going. Okay, guys. So here's where we're going to explore a bit more. We're going to stick to general. This is the general form. I will also say this, most popular. The questions that I'm going to give you most of the time are going to be in general form. So they will look like this for the most part. Okay? Now, when you look at this, you can actually predict a lot of things. Okay? For example, the direction of opening. The direction of the opening of the parabola can be determined by the sign of the leading coefficient A. So if you notice that A is positive, you know without a shadow of a doubt that this thing is going to be pointing up. If A is negative, you know without a doubt, you're expecting, when you put this into your calculator, A is negative, you put it in and it looks like this, you know you did something wrong. You forgot something, okay? If it's negative, it's pointing down. If it's positive, it's pointing up. That's step number 1. Step number 2. A kind of tells us how wide or narrow the parabola will be. So if A, watch here, like these are the boxes here. So if A is anywhere between 0 and 1, not including 0 and 1, but if A is anywhere between 0 and 1, give me one example of anything being between 0 and 1. 0.5, 0.12, 0.0005. Anything that's in between 0 and 1 is going to do the trick. You're expecting a really wide, like it's going to do this. Okay? Or it's going to do this, like it's going to be really open, wide. It's just going to take a long time before you see these arms go up or these arms go down. Okay? Normal, this one is kind of irrelevant, but if A is equal to 1, we just have what we call like a normal width. Like it just looks like this, or it looks like this. Like it could be all over this coordinate plane, but it's just a normal curve. But this, so wide and narrow is the one I want you to really know, right, how that works. If A is greater than 1, okay? So if it's greater than 1, it's going to be very narrow. It's going to do this, right? Narrow, or it could go like this, really narrow. So it could be positive or negative, but we're talking about the actual value being greater than 1. So example, I'm going to use an example. A is going to be 5 in this case. Or A is equal to -5 in this case, because it's pointing down, right? And some students are like, but Mr. Dirksen, it's negative. You said greater than 1, but it's negative. Listen to this part. I'm not talking about, I'm just talking, take away the sign and just look at the number that remains after the sign is taken away. If that's greater than 1, it's going to be a narrow curve. Okay? Let's keep going. the y-intercept of a quadratic function will always, a quadratic function will always have a y-intercept. You can actually highlight that, that's probably important. When the equation is in general form, the y-intercept will be 0c because it is a point on the y-axis. If the equation of a function has brackets to the right-hand side of the equal sign, then it is not in general form. So I will say that. I think this is worth highlighting. If you see brackets, it is not in general form. Which means you need to use the calculator. We need to use the calculator to figure out our y-intercept. Okay? So, let's do a few by observation here. Let's go through this list and you will tell me which one is in general and which one is not. Okay? This one. How do you know? It's y and there's no brackets on the right hand side. Okay? So general. What about this one? The f of x is not what we're looking for here. It could be f of x, it could be y, it could be anything on the left side. What we're looking for is on the right hand side. Are there any brackets in this one? General. Any brackets on this one? General. What about this one? Kind of looks wonky, but no brackets, general. This one? Not general, right? Like if you can tell me that it's not general today, I'm very happy. If you just like general, not general, then you're fine. So this one is, in what form is this one though? If you look at the 3, this is not general. It's vertex, yes, it's vertex form. Highlight this one because this is the anomaly in this one. In this table here, that one is not what we're used to, okay? Okay, let's answer the following question. I would expect you by tomorrow just being able to look at it and be able to tell me which way does it open? Is it up or down? That's what I'm asking you for. For the width, is it wide? Is it normal? Or is it narrow? Okay, that's what I'm asking you for there. And then the y-intercept is just going to be 0c if we have it in general form. Opening. A is negative, correct? So it's going to be down. It's going to go down. Okay? What about a here? A is in front of the x squared term. A is positive. That's going to tell us that this thing is pointing up like this. This one is going down. Okay? What about here? A is negative, so it's going down. We are expecting something like this. Over here, it's kind of sneaky, but look at this. X squared is back here. This is A right here. So it's going to be down as well. A is negative, so it's going down. What about this one? Can I tell which way it's going to open just like that? Yes, because this is still A, right? A is always in front no matter what. So A is negative, so we're expecting this to go down. So now we figured out that. By the way, these two can be determined by look at A to answer both of these. Okay? On the side here, I look at A to determine the opening and the width. Over here, A is greater than 1, correct? So this is narrow. A is greater than 1, correct? Narrow. I know you're going to look at this maybe at home. You're like, but Mr. Dirksen, a is not greater than 1. A is negative 2, right? I'm looking at just the value. Strip away everything around it and just look at that value. It is greater than 1. Okay. This one, a is greater than 1, narrow. Over here, look at a. A is half, right? A here is between 0 and 1. It's 0.5, right? So this is going to be a wider curve. Over here, A is also between 0 and 1, so it's also wide. So if these two, you can just do that by looking at A. You don't have to do any math. You just have to know your stuff. Okay? Y-intercept. Is this in general form? Yes. If I had to state the y-intercept, you would go 0. There is a 0 just hanging around there. Okay? So this would be 0, 0. I'm going to highlight the fact that I took that 0. What do we know 0, 0 as? This is a fun fact. 0, 0 is called the what? Starts with an O. Origin. We call that the origin. So this is also AKA origin. This would be smack dab in the middle of our graph, right? It's going right there. This, what is the y-intercept here? 0, negative 2. What does that mean? It means that this parabola, where's 0, negative 2? This is 0. It's going to be, if this is negative 1, negative 2 is right here. It's going to go through there. Okay? It's either going to do this, right? Something like that. We know it's going up, and we know it's going through there. We know that for sure. Okay? Next, this one, the y-intercept. Can I use the 0 thing? Yes. Why, Mr. Dirksen? Because it's in general form. So my constant is 9. So this would just be plus 9. So if you wanted to graph it, 0, 9, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9 over here. And this is pointing down, so it's going to do something like this perhaps. Okay? We don't know if it's going to be offset to the right or to the left. We don't know, but it's going to go through there for sure. Next, what's the y-intercept for this one? Is there a constant here? Not visible, but it is there. It's a plus 0 at the end here somewhere. So this is just 0, 0 as well. And this one, let me make this mistake on purpose. I know this one, 0, negative 3, don't copy it. Is that correct? Nope, because it's not in general form. We can't do it. So this is a little bit more work. So watch this. This is going to require a little bit of algebra here. What is x equal to at the y-intercept? What is x equal to? Make sure you follow. I'm pointing to it. 0, right? Yeah, it's like I'm giving away a lot here. So what we're going to do is we're going to make x equal to 0. You want that red pen on that one so it sticks out? 0 plus 2 squared minus 3. What is 0 plus 2? 2. What is 2 squared? 4. Minus 3. And now you can grab your calculator. In fact, you could have done that already earlier. I'm okay with that. You just type in negative 0.91 bracket 4, close the bracket, minus 3, and you get negative 6.64. That is your y-intercept. So you go back up here and you say, well, I know it's 0 for sure because we're asking for y-intercept, and that's going to be negative 6.64. I will box this in. I have some good news for you because later on when I show you the features of the calculator, you can skip this step and find it a different way. Okay. All right. This is your first piece of the homework for tomorrow. I'm going to continue though. I want you to fill in this table. Real quick. Is this general? First one? Yes. Second one? Nope. So you go not general. Is this one? The third one? Yes. The fourth one? Yes. The last one? Nope. Not general. So what does that mean when it's not general? Can we just get the y-intercept off of our equation? No. You're going to have to do your favorite, algebra, right? Yeah. So I want you to do that work underneath. See how you do. It's not a big deal if you get it wrong, but at least try. Okay? All right. Keep going. A lot more fun stuff coming your way. You have a weird notion of fun, Mr. Dirksen. Okay, here's the vertex, okay? Very important. It is probably one of the most important points in the entire unit revolves around the vertex. A lot of it at least, okay? So on page 5, the fourth thing we're going to talk about is the vertex. It has coordinates x, y, of course, no surprises. It is the point where the parabola changes direction. And here's where I use a different color. It can either be, in certain cases, the highest point, which is the maximum, or it can, in certain instances, be the lowest point. It cannot be both. It cannot be both. It's either or. It depends on which way is it pointing, basically. Okay. So, in this case, let's just make a parabola, and I'm going to show you how to draw a very nice parabola, okay? You just put a point, this is my vertex here, and I go from there, and I go and make a nice curve pointing up in this case, and then I go back to my vertex, and I try to mimic this one. They're symmetric. They're exactly opposite each other. So I try to, it's like a basket almost, right? A bowl. So this is the vertex. This is the xy coordinates of that. Okay, this is the vertex, which always has coordinates xy. In this case, it's the minimum. It's the minimum. How do you find it using your calculator? Write this down. Second trace min. For now, that means nothing to you. But in a bit, that's going to mean everything, okay? So this is where it's the lowest. However, it could also be somewhere here. Let's make a dot, a vertex point right there. And from there, I make leg number 1. And then I make another leg going this way. So we make them look different because they're going to come in all shapes and sizes, okay? And of course, that point that we're really interested in is xy. This is my vertex as well, in this case, and it would be the max. What are we going to press to find the vertex? I wonder if you can already figure that out. Second trace, you guessed it, max. So this is the highest. In this case, it is the lowest point this graph ever reaches. Here, it's the highest point it ever reaches, okay? All right, let's keep going. Let me highlight the keystrokes. Those are the keystrokes, we call them, the keys. So good news for you is you don't have to do nearly as much algebra as you did last year. But on the flip side, I need you to at least tell me what you're pressing to get to the functions you're using. That is at the very, that's showing your work. So now I hope you know what the vertex is. It's a specific point. And there's only one of them per parabola, okay? No parabola has more than one vertex. The coordinates of the vertex provides us with two additional pieces of information. So from the vertex, we know that it's x, y. And if you look at the coordinates, the x gives us this, and the y gives us this. From the x, we can come up with the equation of the axis of symmetry. What is that? I want you to highlight axis of symmetry. I'm going to go AOS from now on. It is a vertical line that cuts the parabola in identical halves, and therefore it goes through the vertex. So I'm going to use a color for it. I'm going to use orange and green if you want to have the same colors. Let's first, I'm going to highlight this yet here. The equation of the max. So the key word is, does it say equation? If it says equation of the axis of symmetry, or equation of either the maximum or minimum, it's a horizontal line that goes through the vertex as well. So these are imaginary lines, okay? So here's what I want you to know. This is a parabola, right? Can you see the vertex? Yes, clearly. Over here, you can also see the vertex. So what happens is, at the vertex, there are two lines that cut through that. One is called the axis of symmetry. That is the AOS. AOS. And the way we write it is we say, the equation of this imaginary line is x is equal to whatever the x value of the vertex is. What is it in this case? It's 2, right? So the equation of this line right here is 2. X is equal to 2. It's a vertical line. Okay? Let's do the same thing for our parabola here, which is pointing up. You go right through the vertex, and so that's what we call the axis of symmetry. It is important that you understand that this cuts it in half, okay? So if you were to fold it along that vertical line, you would actually line up perfectly, right, with this side. So each leg is like the same distance apart from the center. So anywhere on this leg here, if you stop there and you count 1, 2, 3.5 steps, let's say, it will take you 3.5 steps as well to go from the other side to the center. It's the same distance all along. So here it's x is equal to -2.3. That is the axis of symmetry. Equation of the axis of symmetry. Now, there's the other imaginary line, which is a horizontal line going through the vertex. And that is the y value of the vertex gives you that. The y value of the vertex gives you that. So this equation, what is this equation of the min or of the max? What is the vertex? That's the highest point. So it's actually of the max. And that'd be y is equal to 3. Okay? That one isn't as important, but we'll still take care of it. Go down to this one. At the vertex, there's a horizontal line that crosses it. What kind of equation is this one? Equation of the, yes. And this is y is equal to the y value of the vertex, which is negative 3.5. It's a constant. Both of them are constant functions, right, guys? They're constant. They're staying put. Yeah. So this unit will take up a lot of space on your study sheet, and that's fine. Half a page is not a problem. Okay. Keep going. I told you I'm going to overwhelm you, so if I'm going a little bit too fast, please take a time to watch it and make sure you understand you have everything filled in. The next important thing, this is probably the second most important thing. So there's vertex and then there's X-intercepts. X-intercepts, a quadratic function can have up to 2 X-intercepts. Notice a pattern for applied 12. The degree of the function tells you how many X-intercepts are possible. So this is what I'm going to say. If you have x to the 1, there's only one X-intercept ever. That's the max you can ever have with a linear. If it's x2, the maximum you could have is 2 X-intercepts. And x to the power of 3, that's next year. You don't have to worry about a cubic this year, but you could have up to 3 X-intercepts with a cubic. So that's a bit of a pattern, so you know. So there are 3 possible scenarios: no X-intercepts, 1 X-intercept, or 2 X-intercepts. So I'm just going to give you a diagram, and the justification, I'll leave it for now. But you could have a scenario where this thing, you look at the vertex, that's the lowest point that we'll ever get, and you notice that it doesn't cross the x-axis. There's no X-intercept. So it could look like this or like that. You'll just never cross the x-axis. Okay? So I'll just make a note: never crosses the x-axis. 1 X-intercept is when it touches just one time. And guess when that's going to be? That's when the vertex is sitting right on your x-axis. Okay? The vertex is on the x-axis. That's what I want you to write down there. So alternatively, it could also be facing down. Just make sure it doesn't look like a V. In grade 12, if you do a V, you're going to lose marks for a graph that is very sharp. This should always be a smooth transition like that, okay? Because there's actually graphs in pre-cal, if you take pre-cal, that are like a V. They're very sharp like a V. It's a different graph. So that's the case here. 2 X-intercepts, that's when it crosses it twice. Okay? So you've got 2 there, and you've got 2 there. Crosses it, right? Curve, crosses twice. That's it. Okay, let's practice using our calculators a little bit. So, we're going to try these ones here. It's asking us to determine the coordinates of the x-intercept or x-intercepts. And so we use, these are your keystrokes here. Highlight this. To find the x-intercept, we use this right here. I know right now it means nothing to you, but I will walk you through it. Okay? I'm asking you to determine the x-intercept or x-intercepts, the y-intercept, and the vertex of the following show keystrokes. So let's talk about this a little bit. A is negative, right? You see that A is negative? Which way are we expecting this curve to go? We're expecting this to happen, correct? A is greater than 1, so it's going to be a narrow curve. Just by looking at A. This one right here is A. So we can tell that right away. What's the y-intercept? Is this in general form? Sorry, I should have asked. Is this in general form? Yes, no brackets. So my y-intercept is going to be 0, -3. Okay, so let's use our calculators for this. So everybody look up here. I'm going to show you, this is brand new. Okay, I'm going to show you how to do this. Whenever we want to graph in this course, you're going to press y equals. Everybody should be pressing y equals right now. And we're going to make sure that anything that's in there currently is cleared. So go to y1, clear it. Go to y2, clear it as well. There should be nothing in any of the y's. Because look at this. If you scroll down, you can have up to 10 curves graphed all at the same time. Okay? So I'll say this again. How do you quit that screen again, guys? Second mode, you quit to your home screen, right? So everybody should be at the home screen. Let's go press y again. Y equals. That's perfect. Another thing I want you to all do right now is I want you to check if any of these plots, plot 1, 2, or 3, are highlighted. If they are highlighted, I want you to deselect them. So basically what I'm saying is if you're looking at this screen and plot 1 is like highlighted like that in like a dark around it, dark cloud around it, go to it and hit enter, then go back down. It should not be selected. It should not be highlighted. Okay? Because that's going to give us issues. Now, I want you to enter this into your calculator. And please listen to this part because this is causing a lot of students grief. You do not use minus for a leading coefficient ever. You use this negative button. Okay? So you go negative 9.85. Everybody should type this in for now. Negative 9.85, got it? X, do not use the times button. Okay? There's this button right here. See it? That is your X variable button. It's right next to alpha. So press that. And now we want to square it, correct? So you go X2. Press X2. Now we can use minus. After the leading coefficient is done, you go minus 15.05. Don't forget the X. Minus 3. That's what you should have on your screen right now. Okay? Just make sure you got that. Where's the X button? Is right here. Xt theta n, because it has applications for other functions, but we are just worried about the X. Okay? Now we're going to get to the fun part, and hopefully this works for you. It could be that it doesn't work for you. So, in fact, before we graph, I'm going to all ask you to go to Zoom, and I want you to go press Zoom, right? Then you're in this screen. I want you to all go to Zoom Standard. We're all going to look at the same screen. Press Enter when you get to Zoom Standard. And you should see this screen right now. I'm going to pause here once to make sure everybody's... Okay. Oh, you have a problem? Okay. We don't like problems, so I'll fix smart me on that one most of the time. So I can't help you if you mess it up, then it's going to take me a long time to fix it, okay? Anyways, we all see this, hopefully. Now, let's find the vertex. That's the most important thing. So vertex, I'm going to tell you what to press. We're going to go second, trace. What do you think we have to press, max or min? Max, there we go. You are awake. So let's go ahead and do that. I'm going to try to have my calculator on there at all times. So second, where is trace? It's right up here. Everybody look up. Trace is right here next to graph. You're going to be very familiar with it after. And we select max. Select maximum. Okay? Hit enter. Now, you got to pay attention to this part. What is the calculator asking here? Left bound. What is that? It says, give me a left point, a point to the left of where the vertex is. Where is the vertex right now? Put your pencil on it. Don't press too hard, okay? Don't crack the screen or anything. Let's go to the left of that point. So grab your arrow and keep pressing left or hold it, it doesn't matter, until you get over to the left side. Mr. Erickson, I don't see my cursor. I don't see this thing that you're looking at. Mine is not even on the screen. Watch, I'm going to make mine disappear. Like, where is my cursor? Look at these coordinates. It's telling you where it is. So if you move your arrow, oh, I see, it's like, oh, it's coming up. It's coming up to the, there it is, right? So you want it anywhere to the left of the vertex. Hit enter. Now what is it asking for? Right boundary. So you got to go to the right. So keep pressing right arrow until you get somewhere to the right of that vertex. Hit enter. And guess is just saying, it's just waiting for you. It's like, do you want me to start? That's basically what this is for. So just hit enter one more time. And it should be blinking right exactly where it's supposed, where the vertex is supposed to be. So what is the coordinate? It's right here. You have got your x and your y variable. So write that down. So I'm going to go negative 0.76, 2 decimals, right? And it's 2.75. Just like that. We found the vertex now. Let's find the x. How many x-intercepts does this thing have? 2, right? So let's find the x-intercept. We know it's x-intercepts, so we're going to have 2 of them. One of them is going to be something 0, and the other one is going to be something 0. We know that. We're going to have 2 coordinates. I want to do this before we go because I want you to try this at home. We do this. Watch this. We're going to draw a line under y2, and we're going to make that 0. We're going to draw a line right on the x-axis. Then we're going to go second, trace, intercept. Second, trace, intersect after that step. So, copy this down. Then go back to your calculator. Then you go press y equals. Anytime you want to graph something, go to y equals. Go to your second y, right, y2, and type in 0. That's it. As soon as you type 0, the equal sign should highlight, which means it's active. Okay? Now hit graph. You should see a red line right on the x-axis. So this is my strategy. The intersection of the line, the red line, and the blue line is going to give me the first x-intercept. The intersection of those 2 lines, again, is going to give me the second x-intercept. okay? So second, press it, second, trace, intersect. That's the fifth option. Select it, please. And you should see at the top, watch this, calc intersect. That means like you're in that mode right now. Which one do you want to find first? I'm closer to this one, okay? So I'm just going to press enter. And then it jumps to the red line, right? And just make sure it's anywhere close to that point you want to find the intersection for. I hit enter again. And when it says guess, you enter one more time, and it should stop right at that intersection. And there it is, negative 0.240. So that's my first one. The next one, second trace intersect again. You got to do this again. Second trace intersect. Where is the intersection? It's on this side, right? So what do? I go arrow to the left on the parabola and get closer to that second intersection I'm interested in. Hit enter, and it usually follows you. See how the next one was very close to it on the red? It usually follows you. Just hit enter one more time, and enter when it says guess. There's your second X-intercept, negative 1.29. It's very blurry, right? Negative 1.29. And there you have the Y-intercept, the vertex, the X-intercepts. These three, folks, are going to be super important to graph these things. We're going to graph a lot of them by hand. So we need our X-intercepts or X-intercept, it depends on the scenario, the vertex, and the Y-intercept. Homework. I want you to try this with the other one, with this one here. What else is homework? Remember that table I talked about earlier? That table? If you want to use your calculator with those ones as well, go for it. Thank you, guys.